This video introduces the Radout. The Radout is a LoRa-based radio with serial output. The Radout is integrated into the AR1 on a buoy and is ideal for remote ponds and lakes that are outside cellular coverage. It can also be used for systems needing to control pumps, gates or intakes based on measurements from a buoy system at a shore-based system. The Radout provides a short distance radio output from the AR1 buoy to the Radout base. It includes the two parts. The Radout is integrated inside the AR1 and must be ordered at the time of manufacturing, and the Radout base station. The AR1 activates the internal Radout when a new measurement is made and transmits that data to be received by the Radout base. The Radout base comes with U-bolt pole mounting that uses the flange points on the enclosure. It comes with a 5-meter molded cable, and the cable has two USB adapters, one to provide serial communications and the second to provide 12-volt power from the USB 5-volt source. You may also remove the wires into the adapters and connect those into your own data logger or your controller if you want to take control actions based on measurements from a buoy. This shows the setup of our test system. So we are connected via USB to the serial port in the bottom of the AR1, and we've got a Radout base station connected to USB ports. One port providing the serial interface so we can receive the serial data, and the second port providing 12-volt power to the Radout from the USB 5-volt source. So this is a 5 to 12-volt adapter that provides power to the Radout. You don't have to use these. These are only required if you're connecting the Radout base to a PC. If you're connecting the Radout base to a data logger or controller, you just use the wires that connect into the adapters. Okay, so now we'll have a look at the software. So in this setup, we've got dev config, which is connected to the AR1 on the buoy. For this example, we're just using a USB connection. And then we've got the Radout base, which we've just got connected to a terminal program on the right-hand side that will be showing us the serial output from the Radout base. So on the AR1, we go to the data monitor public table, and we can see that it's the same as normal programs where we've got all the measurements, and we keep scrolling down until we've got the control fields. Now, if you do a read now, the system will go and take a new sensor measurement, and at the completion of the new sensor measurement, will activate send Radout, which will cause a message to be sent by the AR1 to the base station. So what we're going to do is we're going to skip the measurement part and just send Radout by setting it to any non-zero value that gets interpreted as -1, which is true. Now, if we scroll up to the top, we can check the message, and we can see that it's turning on the ports, and we'll see shortly that it is trying to transmit the Radout message from the AR1 to the shore station. So I've got a terminal program set up that is listening to traffic from the Radout and will show us exactly what is sent from the data logger. And there we've seen our first measurement. So it starts with $1 to denote the start of the message, and it ends with a star and a checksum to make sure that the data is valid. And the construction of the message is it's 2 digits for the year, 23, 2 digits for the month, 06, June, 2 digits for the day, which is the 8th of June, and then we have the time, which is 2-digit hour, 2-digit minute, 2-digit second, and then we have two values that are being transmitted in this case. They can be whatever you want. They are programmable in the AR1. You can take any parameter that the AR1 measures and you can transmit them using the Radout, and you can transmit a bunch of them if you want more than just a few, like the example I have here. And the checksum can be used to make sure that the message that is received has been received correctly by using a checksum calculation method called an exclusive OR. So that is an instruction built into the Campbell data logger, and we have code available to you to decode this data and construct each one of them into a public variable, checking that the checksum is correct. Okay, so that's it in a very basic view. The AO1 takes a measurement, the AO1 builds a message, the AO1 transmits it using the internal radio, and the shore station receives it, and it receives a bunch within quick succession so that you have a chance to decode if one packet is missed. And then the AR1 will go back into sleep mode, powering down its radio to make sure that it operates in a very power efficient state. Okay, so if you need any help decoding these messages, let us know. We do have example code available. Otherwise, as you can see, it is a very simple radio link that is versatile enough to connect to a wide variety of data loggers, controllers, RTUs, PLCs, things like that. And yeah, once you've got these measurements, it's easy to make control decisions and set outputs depending on what those measurements are. And that's really the power of Radout. All right, thank you very much.